Welcome to Unit 2, Lesson 6. This is our last lesson in Unit 2, so I'm really excited to share this one with you, 4th graders. It is a little bit trickier than some of the other concepts we've been studying, so as always, do your best and please ask questions if you need a little bit extra help. Today we're looking at perimeter and area of complex figures. Now, we call them complex figures because they're made up of more than one rectangle, square, or other figure. As you can see in my visual example here, I have quite a few complex figures. You'll notice that these are made complex because they look like they're two or more figures that have been put together. For example, this teal colored shape looks like two rectangles, if I split it here, that have been put together. An example word problem you might hear about this is, say, someone created a pool and then decided to extend upon their pool. Then they may ask you, what is the new perimeter and what is the new area of our extended pool? This blue complex figure looks as though it is almost three rectangles that have been put together. Now you'll notice that I'm dividing these complex figures. This would make it a lot easier for me to solve. So I could solve for all of these sides in order to find the perimeter. This could even make one large side. And then I could solve for the area of this rectangle on the left. I could solve for the area of the middle rectangle. And then finally the rectangle on the right. And I might add those all together. I could find the area for the whole complex figure. That's essentially what we'll be doing today. We'll be finding the complex figure, breaking it down into smaller shapes, and then looking for the perimeter and area. Notice that this shape actually breaks into a large square and some smaller rectangles. Or, actually, I saw a better idea of how I could break this down. I might even break this into quite a few rectangles here. This one's a very complex figure. So we've got a square here and then three separate rectangles. That one would be tricky to solve for. But again, you would just have to take it part by part and piece by piece and take your time. As a quick refresher of our important terms from this unit, remember that perimeter is adding up all the sides. Key word here is that we're adding up the sides that are on the outside of our figure. Area, we're finding the square units inside of a figure. So you might be finding how many tiles do I need to tile a bathroom floor, or how much grass sod do I need to lay down in the yard in order to cover the entire yard. So here we go. I'm going to show you two examples today. This is my first example I'm going to show you. I'm going to solve for both the perimeter and the area, and then on the third example, you'll get to try it on your own. So for this first complex figure, I notice that it looks like two rectangles that have been put together. I'm drawing this red line as my divider because it will help me a lot when I'm figuring out area. For perimeter, however, I just need to add all of the sides. Add out sides. So in order to do that, I notice that I have a few blank spots. So first thing I'm going to do is solve for those blank spots. Now, I can see that this is a rectangle here, and I have two pairs of equal sides here. So that means if this length is 5 inches, across the way on the bottom would also be 5 inches. Then on my longer rectangle here, I notice that if this side is 2 inches, the opposite bottom side would also be 2 inches. Now on this next piece, it gets a little bit trickier. This whole edge is 9 inches. So that means that this portion is going to be less than that. I can't just write 9 over there because I know that that's less than 9. So in order to solve for this, I'm going to have to actually use this long side of 9 inches and subtract the pieces that are already there. So I know that this piece here is 3 inches. due to the fact that the side across from it is 3 inches. This side here is 3 inches because it's labeled that. Together, that is a side of 6 inches. Well, if this whole side is 9, this piece here is 6, what's left over? 9 minus 6. This last portion has to be 3 inches as well. So that's a way to solve for a side that's smaller or a different size than the side across from it, using subtraction or finding the missing number. Now I'm ready to add my numbers. I'm going to make sure I get all of them involved. So I'm starting at the top with my 2 inches plus 3 inches. Notice I'm checking them off as I go. I highly recommend that. Plus 5 inches plus 3 inches plus, I'm going to leave a little space here, 5 inches plus 3 inches plus the bottom 2 inches, and finally my long side plus 9 inches. Notice I did not include this 3. That's because it's inside my figure, so it doesn't count towards perimeter because perimeter is just the outside. So now I'm going to start adding some numbers here. 2 plus 3 is 5, plus 5 plus 3 is 8. I'm going to write that down here, 5 plus 8. I'm going to combine some more numbers. This 5 plus 3 will give me 8, so plus 8. And this 2 plus 9 will give me 11, plus 11. Awesome. So now I'm going to add 5 plus 8, which is 13, plus I'm going to add 8 plus 11, which is 19. And then I'm quickly going to line up my numbers to make sure I add correctly. 19 plus 13, 3 plus 9 gives me 12. Carry my 1, 1, 2, 3. So I end up with 32 inches for my perimeter. Perimeter probably takes the longest due to the fact that you have so many sides involved on a complex figure, and you have to make sure that you get every single outside. When we're looking for the area, I'm going to have to go back and remember the 2 original figures that I split this complex figure into. That was a long, tall rectangle here and a rectangle off to the right. Now I know the dimensions of these rectangles. The tall one is 9 by 2, which remember I find area by taking length times width when I'm dealing with rectangles. So that would mean 9 times 2 equals 18 for the long, tall rectangle. Then for this rectangle here on the right side, I know that the dimensions are 5 by 3. So for that rectangle, I need to take 5 times 3, and that will give me 15. So altogether, in order to find the area of the entire complex figure, I need to add those 2 rectangle areas together. So 18 plus 15, 8 plus 5 is 13. Carry the 1, 1, 2, 3. So my area is 33 inches squared. We are ready for another complex figure. I'll walk you through how to solve this one, and after that, it will be your turn to try it. First thing I'm going to do is solve for perimeter, since that's the one that does take a little bit longer, so I need to add up the outsides. I already can tell I have a few sides that are missing measurements, so first I need to solve for those measurements. I noticed that one of those measurements is this bottom baseline or length. And in order to solve for that one, I can tell that it is equal to the top line of 10 centimeters. So looking at that, I can tell that the bottom one will also be 10 centimeters. This one here is going to be a little bit trickier. In order to solve for that one, I don't have a nice, beautiful line up above it that matches it perfectly. However, I do have 2 lines that end up equaling the same length, which I can tell visually here, they end up in the same spot. So what I could do is add those 2 lines together to get this missing length. So that requires me to add 5 plus 2 to solve for this missing length of 7 centimeters. So in that regard, I use two sides to help me figure out and add together to find the one missing. All right, I'm going to delete some of my work here so that I have a nice working space. The last side I'm looking for is this long side one. In order to find that, I'm going to have to do some addition again. There isn't a nice long line over here on the right. I wish there was, but I do see that it's composed of different line segment parts. So in order to find this long side, I can add these sides up. So 3 plus 4 gives me 7, and 7 plus 4 equals 11, and then 11 plus 3 equals 14. So now that I've solved for all of these missing pieces, I'm going to get my workspace ready here by getting rid of some of these lines that I've drawn. And that way, I'll be ready to work. Okay, so in order to find perimeter, remember we add up all of the outsides. So I'm going to start over here and start checking off. 14 plus 10, make that look like a plus, there we go. 14 plus 10 plus 3 plus, this one is tricky, it's almost hiding there, 2 plus 4 plus 5 plus 4, oh, this is going to be a long one, plus 7 plus 3, and finally plus 10. I'm going to start breaking it down, so here I see 24. Here, 3 plus 2 gives me 5, plus 5. 4 plus 5 gives me 9, so plus 9. And I have 4 plus 7, which would give me 11. And then 3 plus 10 gives me 13. So let's start adding together. Here I see I have 29, plus 9 plus 11 is 20. Plus 13. All right, I'm going to start by going left to right. So 29 plus 20 will give me 49. And then I'm going to line up my numbers to add the last 13. So 49 plus 13. As you can see, there's a lot of work involved. 9 plus 3 is 12. Carry the 1, 4, 5, 6. So this one is 62 centimeters in perimeter. Again, it took us a long time because we had to solve for those missing pieces and then add all of our sides together. Now we get to do the fun part of finding our area. First thing I want to do is break it down into shapes that I recognize. On the bottom, I can make an easy rectangle here. This one is 10 by 3 centimeters, so remember that area is length times width. So 10 times 3, that's 30 centimeters squared for an area. So I'll get that ready to add to my other ones, so 30 plus. I see here that I can do a rectangle that's 4 by, don't know that yet. But I can solve for it by remembering that this whole side is 10 centimeters. This portion of the side is 7. So 7 plus what gives me 10 centimeters? Oh, well, I know that that's 3. Yay! So I used a little missing number action to solve for that. So now I have a rectangle that's 4 by 3 centimeters. 4 times 3, length times width, is 12. Get that ready to add to my other rectangle area. Here I can make a rectangle again. This one, again, I can see I have a 4 centimeters ready to go. This 5, though, is only for this portion of the rectangle. But since I just solved for the 3 in this rectangle, I know that the corresponding top piece will also be 3. So all together, this side is 8. So now I have a rectangle that's 8 by 4 centimeters, and that will give me an area of 8 times 4, which is 32. Then I just have one more rectangle on top, which is nice and simple because I already have the dimensions 10 by 3, length times width. Remember that this 2 is part of this whole 10 section. So it's 10 times 3 for another area of 30. So I'm going to start by adding 30 plus 12. That gives me 42. And I'm going to start again by adding 32 plus 30. That gives me 62. Last step is I just need to add 62 plus 42 to get my final area. 2 plus 2 is 4, 6 plus 4 is 10. So altogether, this complex figure has an area of 104 centimeters squared. Whew! So they are called complex figures for a reason, fourth graders. They are very complex. But again, take your time, break it down, use my examples to help you. Whew, I'm a little bit tired after doing all those examples. It's your turn to try it yourself on our ticket. I just gave you one problem to do today because as you saw in my examples, they take quite a while and they take a lot of brain power. So take your time, remember to break it down piece by piece. You'll need to solve for both the perimeter and area of this complex figure. You will do great.